What is quantum computing? People assume quantum computing is a whole different system, some alien system powered by glowing blue liquid in a pod, speaking in symbols no one understands. But here's the truth. It still runs on electricity. It still speaks binary. It's not what it processes that's different. It's how. You don't need to understand quantum physics. You just need a coin. Let me explain. All computers speak in binary, just ones and zeros. A 0 means a circuit is off, and a 1 means a circuit is on. Remember those school science lessons, hooking up a battery, a wire, and a bulb? That's it, that's binary. Now imagine billions of those circuits, all packed into your computer's motherboard, GPU and CPU. That's how computers store and process everything, by flipping those switches on and off, millions of times per second. Letters, numbers, code, everything. It's fast, it's reliable, and it's all done with binary. For example, 01000001 is binary for the letter A. Each 1 or 0 is a bit, and put them together, you get data. Everything from letters to images to code. And classical computers store bits as solid states, either a 1 or a 0, no in between. Just like flipping a coin, it lands on heads or tails, that's it. Quantum computers, they change the rules. They still use binary, but with a twist. Qubits, or quantum bits. A qubit is like a bit that hasn't made up its mind yet. It can be 0, 1, or both at the same time, until you check. That's called superposition. So imagine a coin spinning in the air. Not heads or tails yet, just both. Now imagine flipping lots of those coins at once. That's how quantum computers explore every possibility, all at once. But it gets weirder. Quantum computers use waves of probability, and these waves interfere. Wrong answers? They cancel each other out. Right answers? They reinforce each other. Just like ripples on the water, some waves crash, others build up, and the result, the right answer, rises to the surface. That's constructive interference. And when wrong answers cancel out, that's destructive interference. But that state where it holds all possibilities, it doesn't last forever. Eventually you need an answer, and when we measure the qubit, we force it to decide 0 or 1. That's called collapse. It picks a side based on the physics, the math, and how the system's been set up. So how does this actually help us? Let's say you're trying to unlock a door. A classical computer is like trying every key one by one until it works. A quantum computer, it scans the lot. It figures out which key won't fit all at once, and locks in the best option based on probability. That's why it's so fast. Not because it skips steps, but because it explores all the steps in parallel. But wait, your phone's got a 64-bit CPU, isn't that multitasking? Yes, modern CPUs and GPUs can handle lots of tasks at once, but here's the catch. They're still running classical logic, which means they process each possibility one at a time, just at insane speeds. So even if it feels like multitasking, it's not the same thing. It's still linear, just very fast. Here's another way to see it. Imagine 4 different paths, only one leading to the answer. A classical computer sends one person down each path, one by one. They go, they return, then they try the next. A quantum computer sends one person and 3 clones. All 4 get explored at once. That's called quantum parallelism. Doing everything simultaneously, then collapsing into one correct outcome. But with that power comes risk. A quantum computer could crack passwords in seconds, trying every possible combo at once. A dream for hackers. But it could also help us simulate molecules, cure diseases, and model the climate in ways classical computers could never. It's a revolution, or a threat we're not ready for. Quantum computers aren't intelligent. They're not aware, but the physics behind them, that's where the real power lies. I hope you enjoyed us breaking this down, bit by bit. Literally.